What's up, Matt 2? Well, welcome back. It's Tuesday. This makes day 5. This is our 5th video here today. It's your 2nd week, and we're coming to you live again from the basement. Hope you guys are doing well. Happy Tuesday. This is our 2nd video of this week. And our goal today is we're going to focus in. Last video, we talked about the 3 different ways we could solve some of these systems. There was graphing, substitution, and see if you can remember the last one. Pause, think about it for a moment. Can you think of that last one from last year? Elimination. All right, so we have 3 ways that we can solve a system of equations. And today we're going to focus on just one of those ways. We're going to focus on substitution. All right, so the way this week's going to work is we spent one day yesterday just kind of introing everything for you. The next 3 videos are probably going to all be on this type of stuff. Okay, today we're going to focus on just one method, and the method we're going to focus on today is substitution. It's a pretty standard method. Hopefully it feels pretty familiar to you, and we're kind of work through some examples and see how that goes. All right, as always, if you need anything, reach out, email me. Again, hope you guys are having a good Tuesday. Let's get after it. Let's do some math. As always, I got you coming live with the fact of the day for Tuesday, March 31st. This one I liked. I don't know if you guys have ever heard your parents say the phrase, "Beam me up, Scotty," but it is a Star Trek reference. And ironically, Captain Kirk never said, "Beam me up, Scotty," in any Star Trek episode. So I'm really blown away. Like, I've heard this saying all the time. I don't know where it came from because they actually never said it in the show. Just something the fans said, I guess. Anyway, I thought that was interesting. We'll go ahead and get ready for some math problems. All right, we are going to work through 3 examples today. The first example that we are going to work through gives us the following system. We have one equation where y equals x squared minus 2x minus 3. And we have another equation where y equals 2x minus 3. And again, I encourage you at this point to kind of pause the video and think, what possible outcomes, what possible solutions exist to this thing? And we talked about these on Monday. I'm kind of seeing how much you remember from yesterday. So pause the video. I encourage you to think about that. What are the possible solutions we would expect from this system? All right, I hope you pause the video. From yesterday, we learned there are 3 possible outcomes here. Outcome number 1, we could have 2 solutions. These 2 lines could intersect at 2 different points. We could also have a case where we have 1 solution. In other words, we'd only have 1 point of intersection. Usually that happens when their equations are tangent to each other. And it is possible to have 0 solutions or no solutions if the graphs, if the equations, the functions don't intersect at all. So again, these are the 3 possible outcomes we can have to this system. And again, today we are going to focus on one specific method for solving these guys, and that method is substitution. Okay, when we're working on substitution, all right, we're seeing what can we plug in for something else. Is there anything we know already? Well, we know these 2 equations are both set equal to y, so the first thing I can do is just set these equations equal to each other. So I can say 2x minus 3 should be equal to, sorry about that glare again, x squared minus 2x minus 3. All right, so we're going to take the equations because they're both set equal to y. I can simply set them equal to each other, but now what? What do I actually do? Well, in order to solve something like this, the first goal, it's going to be very similar to our inequality problems from a couple weeks ago. First step is to get everything to one side. Step 1. Move all terms to one side. That's the first thing we need to do. Here to do this right now, I'm going to try to move everything to the right side of the equation because the left side doesn't have any x squared component. So I'm just going to, I don't want this to be negative. I'm going to try to keep this leading coefficient here for that x squared term positive. So to do that, I'm going to do 2 things. I'm going to add 3 to both sides. Add 3 to both sides, in which case, in this case, they're both actually going to cancel out. All right. I could also, and I don't know if you guys like me doing this in one step, but I'm going to. Yell at me in the video, in the comments if you want. I'm also going to subtract 2x from both sides. So that on my left side, everything's canceling. On the left side, I'm just left with 0. And on the right side, I'm left with, well, it's still equal to, we didn't do anything with our x squared term. minus 2x is going to be minus 4x here. And my 3's cancel out. I actually don't have any other coefficients at that point. All right. So how do we go ahead and solve this problem now? Once we get everything to this point, our second step would be to solve the inequality. Solve. And there are a few ways we could do this. We could do this by factoring is one way. We could see, that's probably, factoring it takes care of most of them. You could also do it, there's completing the square in here. There's quadratic formula in here. Those are all the ways we know how to solve an equation like this. Now this one's a little bit weirder than normally what we usually see because we don't have a constant term here. In this case, we'd still try to factor this guy, and you may notice there's a GCF involved here. These both have an x, so I could pull an x out. If I pull an x out of both, what am I left with? I'm left with x times x would give me x squared, and over here, what times x gives me negative 4x minus 4. Those are still equal to 0. Okay, so I pulled out a GCF. At this point, I'm back to using my zero product property. So I have two possibilities here. That leading term x could be equal to 0, or x minus 4 could be equal to 0. This is still using that zero product property. We just don't have another set of parentheses there. It's just x on the outside. Well, x equals 0, that's fine. I don't have to do anything else with that. On the right side, I need to add 4 to both sides so that x is going to equal positive 4. So what does this tell me? This tells me we have two solutions. This means they intersect at two different points. And the points where they intersect is when x equals 0 and when x equals 4. But that's only part of the solution. I've only found the x coordinate. I need to find the points of intersection. In order to do that, I'm going to have to take my x values, where x equals 0 and x equals positive 4. And I'm going to have to plug those back into the original equation. Now I have options here. Remember, we had two equations. We had y equals 2x minus 3, and we had y equals x squared minus 2x minus 3. Guess what? It does not matter which equation you plug them into, okay? Because we know these equations are equal to each other when x equals 0 and when x equals 4. All right, so it doesn't matter which one you plug these values into. And I'll tell you what, if you have a linear component, that's going to be much easier to plug into. So ignore this bottom one for a moment, and let's just plug into the easier equation. If I plug in x equals 0, y equals 2 times 0 minus 3. So y in this case is going to equal negative 3. All right, so one solution, one point of intersection, when x is 0, y is negative 3. That's one point of intersection. Okay, we didn't just have one solution, we had two. We also need to check when x equals 4. So 2 times when x is 4 minus 3. And we're going to evaluate this guy. 2 times 4 gives me 8 minus 3 equals 5. So when x is 4, y is going to equal 5. So 4 comma 5. So these are going to be the 2 points of my solutions. These are going to be both my answers. And we found those using substitution. I hope that problem was pretty straightforward. Again, the big thing here is once you get everything to one side of the equation, once you get here, when you have everything on one side, we're trying to solve this guy. A lot of times that's going to come down to factoring. Occasionally you may need to complete the square or use the quadratic formula. In this case, we didn't really, we factored it technically, but we didn't need to use the area model or anything like that. We just pulled out a GCF in front and then went from there. Okay, so it kind of depends on the problem, what technique to solve you're going to use. Okay, we'll take a quick break here. We got two more examples to kind of run through, and I'll be right back. All right, let's go ahead and take a look at this next problem here. Our next problem gives the following system. We're told y equals negative x plus 2 quantity squared plus 5. And the other equation we're given is a simple equation, just y equals 5. All right, now I like this problem for two reasons. One, this is still a quadratic up at the top. It looks a little bit different than what we've typically see. This is again given to us. I encourage you to pause and think about what form we have here. Is this standard form, or what's the other form we've been talking about mostly? We have three forms of quadratics. All right. All right, we have three forms of quadratics in this case. Remember, there's standard form, there's factored form, where we have something in terms of factors, and the one we're given here is vertex or graphing form. The other thing that I like about this problem is y equals 5. Just to remind you what that's going to be like, that means y, our value of y, is always going to be 5. That's a horizontal line in terms of our x and y axis. Okay, so we have a horizontal line and a graph of a quadratic, and we're asked to solve. Again, we're using our method of substitution. Now, I will warn you, so far every problem we had has been nice and easy because y doesn't have any leading coefficients. I will tell you, if you ever came to a case where there was something in front of the y, like what if they had said 2y equals 10 here? Well, we can't substitute these in directly. I could divide both sides by 2 to get that bottom equation to be y equals 5, and then I could plug in. But my point is, make sure we're only substituting in if we have things that are exactly equal to each other. Okay? Now, in this case, we're going to solve this just like we would the last problem. So we're going to start by setting them equal to each other. All right, so we're going to say 5 equals negative x plus 2 quantity squared plus 5. And if you remember from the last problem, once we get here, our first step is to get everything on one side of the equal sign. Well, in this case, I'm just going to subtract 5 from both sides. Subtract 5 from both sides. When I do that, my left side's going to be canceled, and I'm left with 0. That's going to be equal to negative x plus 2 quantity squared. And then positive 5 minus 5, well, that's going to cancel as well and leave me with 0. So I don't have a k value out here. Okay, I no longer have this k value. So now I'm left with this equation, 0 equals negative x plus 2 quantity squared. And I need to solve this. Our second step after we get everything to one side was to solve this equation. And this is something we've done kind of in passing, solving something like this when it's given to us in vertex or graphing form. But we can definitely go ahead and tackle this. The first thing I want to do is take care of any value in front of my parentheses. That's the first thing I've got to get rid of. In this case, we got to be careful here. I know it just looks like a negative, but we could always put a 1 out in front. So there's a negative 1 out in front that we need to first divide by. So again, I'm doing all of this to figure out what x is going to be equal to. So I'm trying to get x by itself. First thing here is going to be divide both sides by that a value. In this case, that a value is negative 1. On the right side, negative 1 divided by negative 1, those cancel. 0 divided by negative 1, well, that's still just going to be 0. So we have 0 equals x plus 2 quantity squared. Well, what's the next thing I need to do to get x by itself? I need to get rid of this exponent. So I encourage you to pause this video for a moment and think about how we get rid of this squared term here. Well, remember, whenever we're doing algebra, we have to do the opposite of something to undo it. The opposite of squaring something is taking the square root. Whatever I do to one side, I have to do to the other. So I'm going to square root both sides. The left side, the square root of 0, well, that's still just 0. And on the right side, when I take the square root of x plus 2 quantity squared, now I only have one of those terms. So it's just going to be x plus 2. 0 equals x plus 2. From here, this is a pretty simple problem to solve. I'm going to figure out what x is by subtracting 2 from both sides, so that when those cancel, x is equal to negative 2. So these two equations, y equals negative x plus 2 quantity squared plus 5 and y equal 5, only have one solution. They only intersect at one point. That point is when x equals negative 2. That's okay. Remember, we have 3 possible outcomes here. We could have 2 solutions, 1 solution, or no solutions. In this case, when we solved, we got only one solution. Now, part of the reason that happened is because everything was equal to 0 here. It is possible to have a constant over on this side. And that'd be okay if we had that. It typically means if there's something other than 0 over here, you're still going to end up with 2 solutions. So be careful there. We could still solve this if there was a number over here that wasn't 0. But when we take the square root of any number, we usually get 2 answers, a positive and a minus. There is no positive and minus of 0. That's why here we ended up with just one answer over here, and x equals negative 2. But again, that's only the x value. We still need to figure out the points here. But this is kind of interesting. Look at the second equation we had was y equals 5, right? There's nothing to plug into at that point. What that means is that's my y value. It kind of is easy when it gives it to us like this. So the point of intersection, when x equals negative 2, y is going to equal positive 5. And if you didn't believe me right there, we could plug it into our first equation, the quadratic. We could say y equals negative. We were looking at this one, x equals negative 2 So we're plugging in negative 2 for x plus 2, quantity squared, plus 5. Well, what's negative 2 plus 2? That's going to go to 0. So we have y equals negative 0 squared plus 5. Well, 0 squared is 0. 0 times negative is 0. So we're essentially saying 0 plus 5 here. So y is going to equal 5. So in case you didn't believe me from that first part, yeah, we can prove it. And we end up with one solution here at the point, negative 2, comma 5. All right, again, I like that problem a lot because we're starting off with a different form. We're given something in vertex form. And I don't think we've done a lot of problems where we actually have to solve something at this stage where we have this negative x plus 2 quantity squared equal to some value. All right, I've got one more example for us. Take another quick break and we'll knock out one more problem. All right, guys, we got one more problem to kind of tackle here. And the problem today, or this time, is we're again given a quadratic problem up at the top, x squared minus 2x plus 4, and a linear equation, 2y equals 2x minus 2. Now, the first thing you might notice here is we're not just set up equal to y in this case. So we can't easily just set these guys equal to each other and substitute. Okay? I need this to be y on this side. Well, I'm not out of luck. The first thing I might need to do in this case, is divide both sides of my equation by 2. Now remember, when you're dividing both sides by 2 here on the right-hand side, I need to divide everything by 2. So you may get some fractions here depending on the terms. I set this one up nice and easy for us. On the left-hand side, we end up with just y equals 2x divided by 2 is going to be 1x. Negative 2 divided by 2 is going to be negative 1. Another way you could think about splitting this up, this is equivalent to 2x divided by 2 minus 2 divided by 2. So remember, when we're dividing both sides by the same number, you got to divide both terms separately. Okay? So that takes care of this. So now we actually can substitute these guys in. This is the new second equation, and we're going to substitute that in with y equals x squared minus 2x plus 4. So again, now that these are both equal to y, I'm going to go ahead and set them equal to each other. I'm going to ignore this 1 out in front for a moment. So I'm going to say x minus 1 equals x squared minus 2x plus 4. Okay? Once we set them equal to each other, our first step is to get everything on one side. Again, I'm going to start by moving everything to the right. To do that, I'm going to add 1 to both sides. I'm going to add 1 to both sides of the equation. All right, so I cancel over here. I also need to subtract x from both sides. Minus x. I'm going to do that to both sides of the equation. When I finish, on the left side of my equation, I'm going to get 0. That's going to be equal to x squared minus 2x minus 1x is going to be minus 3x. Positive 4 plus 1 is going to give me positive 5. So now I've got a new quadratic that I'm going to try to solve here. All right, and that quadratic again is x squared minus 3x plus 5, and that's equal to 0. All right, once we get everything here, the goal is to solve. The first thing we might want to try to do here is factor this guy. So we could build our area model. We haven't had to factor yet this week. X squared, positive 5. So I'm looking for factors of 5x squared. And they have to add up to my middle term, which is negative 3. But the only factors of 5 are 5 and 1. I could add or subtract those to get 6 or to get 4, but I can never get to my middle term of negative 3. So this equation right off the bat here isn't factorable. Well, what do we do if the equation's not factorable? What are some other ways we could solve? We could try to complete the square. That's a little bit time involved. One way that should always work is to use our quadratic formula. So that's the one I'm going to use here today. Let's see, our quadratic formula is x equals, let's see, opposite of b, plus or minus square root of b squared minus 4 times a times c, all of that divided by 2a. All right, this is our quadratic formula. Hopefully you haven't forgotten that completely. I even thought about singing you the song right now. But anyway, let's see if we can plug these in. Remember, there should be no x's for my a, b, and c here. It should just be the coefficients in front. For that leading term, the x squared term, the a value, the number in front, we can always put a 1. All right, so there should not be any variables. There should be no x's inside. The only x should be x equals. That should be the only x we see. Okay, so let's go ahead and try to plug in here. Opposite of b, well, my b value is originally negative 3x. So I'm going to do the opposite of negative 3, which is going to be positive 3. Plus or minus the square root of b squared, where b was negative 3. So I'm going to take my negative 3. I'm going to square it. Minus 4 times a. A is 1. C in this case is going to be 5. And that's all going to be divided by 2 times a, which is 1. Okay, so we have positive 3 plus or minus the square root of negative 3 squared minus 4 times 1 times 5, all divided by 2 times 1. All right, let's break this down one step at a time. I like to start with inside my parentheses, or my square root sign first. So I'm going to leave that positive 3 on the outside. We're not messing with that yet. We have our square root symbol. Negative 3 squared gives me positive 9. I'm going to subtract from that 4 times 1 times 5. Well, 4 times 1 is 4, times 5 is going to be 20. And that's all over 2 times 1 is just going to be 2. All right, so we kind of simplified this a little bit. Let's take the next step. Let's simplify underneath my radical. 9 minus 20 is going to give me 3 plus or minus the square root of 9 minus 20 is going to be negative 11 all over 2. And right here is where we might get a little stuck. Anytime you try to take the square root of a negative number, if you put that in your calculator is going to freak out and tell you it does not exist. Okay? There's something called imaginary numbers, which we talked about a little bit when we introduced this quadratic formula. But we currently do not have a way to solve imaginary numbers. So anytime you start to use your quadratic equation and you get a negative symbol inside that radical, that tells us we do not have real solutions. We have what's known as imaginary solutions. Imaginary solutions. Okay? Imaginary solutions essentially mean, if you remember way back from chapter 5, it means they're not going to actually intersect. So in this case, when we have a negative underneath the radical, we can't finish solving this. All right? So in this case, we would say we have no solution to this problem. They do not intersect, no solution. There are no points. These lines, these functions, do not intersect. Okay? You should always, just because you can't factor it doesn't mean the quadratic formula is going to fail like it did in this case. So just because you see it's not factorable and you say, oh, well, I got to use my quadratic formula, that's going to mean it's no solutions. That's not entirely true. The only reason this didn't work this time is because when we tried to use our quadratic formula, we got a negative number here. If this number had been positive, we still could have found the answer. We would have gotten some ugly decimals. I'd have to take the square root of 11, add that to 3, divide by 2. So it still can work. But again, what screwed us up today, the reason we know we have no solutions now is because we had a negative number underneath the radical. That was the big reason why. The negative number in the radical. Okay? So I hope that went well for you guys. We went over pretty much the 3 possible outcomes we can have here. I showed you a 2-solution problem. I hope that went pretty well for you today. We essentially showed you the 3 different types of solutions you can have. Again, you can have 2 solutions, 2 points of intersection, 1 point of intersection, or no points of intersection. Just because you're using the quadratic formula does not mean you're going to have no solutions. So make sure you check that all the way through and see if you can come up with an answer. All right, I hope that went pretty well for you guys. As always, let me know if you have questions about anything. I will see you guys tomorrow.